Let's do a quick review on the microscope, since you've probably already done it in lab. We have the base, we have the light source, we have this barrel structure here that consists of two things. You got your iris diaphragm and you have your condenser. You have the adjustment knobs, the coarse adjustment, the fine adjustment that move the stage. The stage is what houses your slide. It holds your slide just like a stage holds performers. Same thing. We're looking at this. You're not watching an actor in this case, you're looking at a slide. So the stage holds it. Cool thing about most of our scopes at CVC is that they have a stage that is called a mobile stage. So if you look here, see these two knobs? They actually move our stage side to side and forward to back. That makes control of the position of our slide a lot easier. When you magnify quite a bit, let's say 40x with 10x, that's 400 times what the naked eye can see, and you're shifting your slide around to move a specimen so you have a better viewpoint of that specimen, honestly, it isn't easy to do where you're moving enough to move it within the space that you're seeing it and not risking getting it out of that frame completely. Having these dials that allow you to move very minute amounts helps you to keep your specimen within that window that you're looking into. Now, the other thing that's on the stage is this silver contraption here. The silver contraption that you see on the stage is called a stage clip, and it is used to clip your slide in place. So see this angle right here? It's pretty much a right angle. You're going to get the corner of your slide and put it in place there. This over here is a clip. So I can pull that clip back, put my slide in place, and let it go, and it holds my slide so that I don't have to worry about it falling off the stage or moving around the stage. The other thing that this allows me to do, remember I said the stage was mobile? The reason that it helps move your slide around is because this bracket is actually what is being moved to move my slide around. Arm, body, the oculars, which you look through, and for us, it's binocular, meaning it has two places that you look. And right above the stage, you have this piece of silver that's round called a revolving nose piece. The revolving nose piece revolves these little dudes around and allows you to change what your magnifying power is every time you change these guys. These are called objectives. Each objective has a number on it. So, for example, this objective, which I'm going to scoot closer to you, has a 4. The 4 means that it is 4 times bigger than what your naked eye can see. The next objective has a 10. That means that it is 10 times bigger than what your naked eye can see. The next one has a 40. This means that it is 40 times what your naked eye can see. And the last objective that we have on this particular scope has 100. 100 times bigger than what your naked eye can see. So the interesting thing about that is that your ocular, what you're looking through, also has a magnification to it. Right there, it says 10x. This is, all by itself, without the addition of these objectives, gonna increase the size, magnify the image 10 times what your naked eye can see. So when you're looking through these, magnifying 10 times, and you're looking through this, which already magnifies 4 times, the image coming in from this objective is 4 times bigger than what your eye can see. And I'm increasing that by 10 times when I look at the image that's already increased that much through these. That means that you are multiplying the amount of magnification that you see. So when I want to know the final magnification, I would take this multiplied by this and get a final magnification. So 4, which is the objective I'm pointing to, times 10 is 40, meaning it is 40 times bigger than what my naked eye can see. So if I switch to the 10, this is 10 times bigger than what my naked eye can see. This is 10 times bigger. So when I actually do that and use them together, I'm looking at something 100 times bigger than what my naked eye can see because I multiplied 10 times 10. 40. 40 times 10 is 400. 100. 100 times 10 is 1,000. When you use this objective, which is an oil immersion lens, so you wouldn't use it with air, you see things quite a bit bigger, 1,000 times bigger, than what your naked eye can see.